Okay, so if you have not previously seen the question one that I did in my previous video, you can check through the description. There's a link of that video inside there. So this is another possible question that you can get from question one, and this is the setup. I have explained that in the previous video. Now we have a meter rule and a G clamp to a table. So let's just quickly read through this. Clamp the loaded meter rule firmly to the edge of the blade as a horizontal cantilever, as shown above, capable of performing vertical oscillation. So here we're going to place a mass. The mass M is going to be placed at the 95 cm mark. You can see that there. And this is clamped at the 5 cm mark. So this is our meter rule. So I'll just read through and describe all of that. L is the distance between the edge point of the bench and the point on the road where M is attached to the meter rule. So you can see the distance between this and this is L. So you can see that here. So I think we are going to be taking those measurements as the video goes on. So with length, L equals 90 cm. So if L is 90 cm, it means that we are going to place this at the 95 cm or this at the 5 cm. So you see the difference between 95 and 5 is 90. So from here I can start to draw my table because I know that I'm going to get L equals 90 cm. Determine the time for the loaded meter rule to perform 20 oscillation. Repeat once and find the average time T for 20 oscillations. So I'm going to have my time taken twice. So I'm going to have this L in centimeter. So I'm going to have T1 in seconds. Then I'm going to have T2 in seconds. And I have T average, or just T, is equal to T1 plus T2 divided by 2. Then let's see again. So we are going to calculate the period T of oscillation in each case and tabulate it. So I'm going to have T on that table. So this is in seconds. Then I have T in seconds. Then we are going to plot the graph with log 100T. So there's going to be log 100T on this part here. Log 100T. So there's no unit for that because that's just an ordinary number. So that's how my table is going to look like. So my L is 90 cm. I'll repeat the experiment for 85, 80, 75, 70. So I'm going to write 90.00, 85.00, 75, no, 80.00, 75.00, 70.00. So we're going to work with this. So then we are asked to plot the graph of 100T along the vertical axis and log L. So that means we are going to have another column that will have log L. So I'm just going to, so this is log 100T. Then I'll have log L. So that's how my table is going to look at. The good thing about this is that once you draw your table out, you don't need to go to the question. You just use the table to carry out your experiment. So what do? The mass is placed permanently at this. So we have to be reducing this to reduce the length. So we have to be moving this inward to reduce the length by 5 cm each. So let's get the setup. So this is our setup. Placed at the 5 cm mark. So this is the 5 cm mark. Okay, out of the 5 cm mark will be pointed out of the table. So we have this. The mass. Okay, now we were asked to provide optical pins. This is not part of the question. So what they can ask you to do is this, using the optical pins. The optical pin can be attached on this with the mass placed on it. and you determine the depression on this in each case. So you can be asked to do that. So you have the optical pin placed here. You just determine with the mouse on it, determine the depression, record it down. Then when you put the mouse, let's carry that out. So we'll just add that to part of the experiment. So let me clamp this to the 95 cm mark. So this is 95. Okay, so this is another possibility. So you may be asked to take the depression. So you use the length that is going up like this. Or, okay, the one that is going down like this. So we can take this to be the one that is going down. So that's 31.5. So you can record that as 31.5. So that's what you can be asked to do. So you record this depression because of the optical pin. And as you are moving the meter roll, you may be asked to do that all the time. So what you just do is record this. So when you move the meter roll, the length might go up or down. You record the depression again. But this is not part of the video. So I'm just trying to show in case you are asked to do this. So I'm going to remove this. So this time around we are taking 20 oscillations twice. So let's set this into oscillation. So I'm going to set it into vertical oscillation like this. So I can start counting. 1, 2, go. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that is 15.40. So I'm going to take the second one again. So I'm going to take it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 15.87. 15.87. So I'm going to do it for 85. So to get 85, I have to move this to so that the 10 cm mark will be outward. So this is 11:10. So I'll clip it. So this is for 85. So I'm going to go. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's 14.66. So take the other one again. So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 14.57. It's consistent. 14.57. So I'm going to pause the video. Carry out the mission. Yes. Go ahead. Put something on that. If it's put something on that to hold it there.
So I'm going to take our last reading. That is 70 centimeters. 3, 2, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So what's the value?
10.97. Again. 3, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And we got 11.09.
Okay, so record that. So evaluate the tables.
So we're going to evaluate all the
Then I'll come back and show the evaluation. So just, okay, take the average of the second one, then I'll pause the video. Okay, complete the evaluation of the first part and the second part before I pause the video. So complete the evaluation of the first part. As in the whole of this. Complete the whole of this.
Yes.
Complete the whole of this.
So we'll take the period of this, that will be C over 20. That will be 0.73.
So we're taking down to 3 decimal places, right?
Decimal places, yes.
Then take log T for both of them.
100T.
Yes.
So multiply this by
100.
That will be 78.2. Then we take the log of it. That will be 1.8.
Just give it to 3 significant figures. Then take log L.
Then log L, that next.
That will also be 1.95. Okay.
We take the log 100T. That will be log of 73.1. 1.86. Then we take the log of 85. 1.93.
Okay, so I'll pause it and you complete all of that evaluation. Go. Okay, so these are the evaluations, and we evaluated this to 3 decimal places, this to 3 significant figures, and this to 3 significant ones. On a separate video, I'm going to make a graph of the first experiment that we did, and I'm also going to make this graph on those separate videos. Don't forget that there is a video prior to this, and if you're wondering how you can get that video, check the description of this video. You're going to get that video there, the link to the video. And don't forget, if you are good with what we are doing, please try and support this community by putting a token on the bank account that is displaying on your screen right now. Good luck, and see you for some other videos. Don't forget, we're going to do a video on question 2, possible question that you get, and also question 3, which is electricity. See you, and God bless you.